Okay, so enqueue and is passing this pointer. Maybe you can use the ampersand since it is accepting multiple connections. Yeah, since each time it going to accept multiple connections, he is doing that, but I'm not sure. Maybe you can do that. I need to have a check. Anyway, he does that, and you can see there this main PWD is sending like a global context. Okay, so each time it does, he is sending that as a global context. Which, as we seen earlier, he initialized here. So it's a nice, interesting thing. So which kind of brings us to this brings us to a point that we need to explore this enqueue DQ APIs. As you see here, there is only enqueue. DQ will be there somewhere, which means you just add it to the queue, and somewhere somebody or somewhere else he may remove it from the queue. So that is what we can explore next. You can see there the queue part hopefully is done in a separate .c.h file. It is not done in that common .c and common.h. So you can open this queue.h. You can see there he have defined a data structure, and from this data structure we will know that it's a sort of a linked list. So you can see the struct node and node is having a node of next. And then we have added these two APIs. One is enqueue, the next is DQ. DQ, since it is pulling that node out or taking it and subsequently may delete, who knows. Okay, so he's returning this star. This also tells it may be a global variable context of this queue is there, so he's not passing any pointers over here. But if he wishes to make this more look like a library, I think he can approach that way. Again, I'm saying this, I don't want to strictly comment that he have not done, I don't want to review this. Okay, I'm just explaining. I felt maybe he can do is a pointer he can pass, so that you can make it more of a generic stuff rather than expecting a global context. But anyway, you can see there DQ is there and display is there for this queue. He can even put a name of this API as display queue or something like that. So something like that, or else traverse queue or something. Anyway, so that is what is this queue, and hopefully we should able to find in queue.c the implementation of that. So you can see their head is there, tail is there. So this is the global context of this queue. As you see here, if it is null, it has nothing. Then as you subsequently add more items through enqueue, it is going to add more nodes to that, starting from that head. Okay, so you can see that the head is again that struct node underscore t. Okay. Enqueue is there. The thing is, he's doing this new node. Since it is not initialized, he is doing this, and somewhere he is going to assign that new node to the head. You can see there, and then he is checking if tail is null, and so and so. This is a regular linked list, stuff. Yep. So here you can see there the socket part is over here, and new node of this socket file descriptor he's passing there, and he's kind of the main intent of his queue is to take the job and then put it in the queue, because anytime a new connection comes, the main intent of this code is let me just do one thing I can do quickly. We can run this code, okay, so that I can show first a demo of that in action. CD media backups. Yes, so we are here. I can do a make. Let me increase the font size. Yes, so you can see there it is compiled, and I can do one thing. I can run the server first. As you see here, it is waiting, and then I can open a tab, and then I can do client.o, and then here you can see the moment I ran, it accepted the connection, and I can do ls, and this is actually pulling from there, and it is getting here. Okay, so hopefully you can see there, and then I can do hopefully the pwd and stuff like that. Of course, I can't type all the commands, the commands which he supported in the code. Okay, so we can go here and see the command supported over here. Somewhere there is a mention, see there ls cd pwd, so I can even type cd and all, which of course I can do that. Hopefully I can do cd dot dot ls. Yep, see, as you can see, even cd dot dot it is working. So change directory, it is working. And then I can quit by typing by, and then it came out. I'm not sure about this error, but when I tested in the laptop after I got the mail, it worked fine. Okay, maybe the CD or something is not handled. So let me do one more trial, ls, and then I can do a by. Or let me try this. Let me not enter without typing any commands. Okay, I do this ls, typing this by, and it came out. So this is what exactly I saw earlier. So when I enter without any command, I think it is not, he's not handling that. Okay, maybe that is a bug. So which means I don't type any command, but if I enter, it is sending a TCP packet without anything. Okay, so you need to handle, if it has no command, then I just need to ignore that stuff. So something like that. Okay, so hopefully he may fix that, which is fine. So you can see there it is showing, but the main intent is he is saying that it can accept multiple connections. So we can test that. ls, and then we open another tab, and then we can do ls. We can do client, and then we do ls. Hopefully it should connect to both of them simultaneously. You can see there new connection, it is not showing closed, so it is parallelly connected to these two connections. And we can little bit confirm with Wireshark, or we can explore with Wireshark what packets are being exchanged between client and server. See, since it is a local host, I am doing with local host. I do once again this ls, and we can see hopefully the packets here. Yeah, you can see there. Let me see here. See, it is from this source port to this destination port, and if I do here pwd, it should change one of the port numbers. Okay, 54321, whereas here it is 54321. Looks like that may be the server port, or TCP server port. We can confirm by going inside command.h. Yes, you can see there, this is the server port. Okay, you can come back here, and let me stop this, because the annoying thing about TCP is the handshakes. Okay, so you come here and you can see this is one client port and this is the other client port. Okay, yeah, this is 96.327.96 versus this is 327.98. So you have two clients, TCP clients connecting to a TCP server. The TCP server is parallelly handling this multiple client requests, and it is maintaining the connection. Okay, it's not disconnecting after each command and connecting after each command. So that's what is the learning curve. If you are writing some type of multi connection TCP server or something, this is a good architecture to start with. You can remove all this code, retain what is needed. You can really do something with this type of a test or stub code. Okay, so you can see that it is doing that, and you should able to see, if it doesn't encrypt, we should able to see the contents. Yeah, you can see the contents of whatever it is sending from the server to the client, and hopefully from client to the server as well. See here, the command type is pwd, and we got this reply, and he is doing some padding, maybe he is doing, or I am not sure why these zeros are coming. Eventually it is around 1400 bytes it is. So same way, let us see here, even here here it is not padded versus here it is padded. I'm not sure. Anyway, if you come here, you can see there, this is a reply for ls command, and what is the command I sent? So client I've sent is ls command, you can see there, and for which we got all this output sent from server to the client. Okay, yep. So this is the thing, which is why if you go back again here, this enqueue, the whole intent is something, as far as I understood in this short period of time, I think you have a you can have multiple clients, and you have this server, TCP server, and it is having multiple threads. Okay, and we can see from the common.h we have 2 threads. So we try to get the kind of architecture out of it, and then he have a small queue, okay, which is nothing but a linked list. So let me put it as a list. So each time each time you type any command, it comes and then it kind of stays in this list, which means it will be added like a job. Okay, it comes and it will pile up. Okay, so imagine you can do this at a high rate and you can send some type of requests. Okay, see, it is a nice code. Like I said, we can take this and we can really modify and use in multiple ways. Okay, so you have this sort of you have a job queue, and then it is collecting all these jobs, and what happens is whichever thread is free, hopefully it should able to pick that one of the job by doing DQ or something, and then it will execute, and then the client will get that reply back. Okay, so that's what kind of, which is why he's sending the context of that socket file descriptor, so that this guy will run it, and then it will do it will put back in some queue or something, and then it will be sent back. Okay, something like that. Okay, so you can see there in enqueue he's doing this, and then there's a pthread mutex lock, because you should this is a common data structure between many threads, so it should not happen a situation that one thread deletes the node and one thread tries to add and something like that. So to avoid race condition, it's a common sense tells that we need to add some synchronization. Okay, so anyway, so you can see there is synchronizing this, the main aspect of it. See, anytime you can do malloc and all that stuff, but the main thing is when you touch this global context, which is that head and all that tail stuff, when you touch any global context, which is when you need to synchronize, because you don't need to put this lock over here and unnecessarily lock for a long time. Okay, so exactly when that critical section starts, he's putting that lock, so that it will also avoid some efficiencies in the program. So same way you can see there DQ, if you have this, if it is null, of course nothing there, which means the list is empty, so it is nothing there, so it doesn't do anything. Else is doing lock and then getting that access to that and is taking it out. You can see there this is null, and if it is nothing is there, so it is a common deleting a node in the list, but in this case he is picking it and is returning it. So you can see the result is again node star of result, and that is assigned for net and head, and then he is doing this and he is returning it. And in the case of display something, he is doing this, and yeah, it's like a typical traversal, which is why I said he can use even the word like traverse or something, traverse queue or something like that, so that it is in line with this nomenclature. Okay, so it's fine. It's just a traversal. You can see there, it's just displaying. It's useful for programming, debug and stuff. Yes. Okay. We can do one thing. We can go here in server. We can do one thing. We can add. You have this q.c. Yeah, we can call this API as soon as this unlock happens, or before this lock, who knows. Yeah, before this lock I can do that, because again after unlock you need to ensure that it is not getting into some race condition. Okay, somewhere someone is removing, somewhere someone is trying to add. So I can do it debug display here. Let's see if it works. Okay, I go back and close this connection. Hopefully it should stop these two guys as well. So let me close this, and we can compile, and then we can run the server. Yeah, we can run the server and run the client ls. So we are getting this, and what is it has the queue is, you can see there it is showing something. Well, let us see, we can do pwd, and we can see, yeah, you can see there it is doing a debug of that queue. okay, length is so and so, buffer is so and so. So this is the sort of request we got, and yeah. So whatever extent he put, we can add some more attributes if we want to debug, we can do that as well. Okay, client socket is printing, and if we want, we can even print some more things. You see, the queue has this PWD and stuff. If we want, even we can print that as well. So I think it should work. So we can just add with this printf, we should able to add say %yes and temp of PWD. Hopefully it is 0 terminated like any string and not a binary stuff. Where is that q.h? See, you can see there you have this PWD, and then we can debug that. And what else it is? Yeah, that's all. It is a socket file descriptor he is displaying. So instead I can get this way. So I can cancel this and cancel this guy, and then let me compile. What is that? It is yeah, I don't need to derive this. It is directly, I can do this because it's a string, and I can give some hyphen something to delimit. Yes, so you can see there it got compiled, and we can run this, and then we can do ls something, it gone into trouble. So something client this thing temp of PWD %yes. This is what character star path max, which is what, if it is not having 0 termination, then it is an issue. We can do is we can store it in temporary string, and we can do some strcpy and stuff, or memcopy and stuff. I don't want to do that, so let me just comment it out. Anyway, we can debug, okay, debug the whole stuff, and we can once in a while traverse that queue. So let us summarize. We come back to this common. See, it is happening each time it gets any new connections. It is accepting connections in one side, and it is processing these requests in another side. Okay, so that's the architecture. So we go back here. You can see there one side it is accepting connections, and one side asynchronously it is going to process the connections. It is going to process these jobs in these threads, which is what we can quickly go through. So you can see there, any command you type, it is going to come here in the list, and we can go Wireshark and check whether it is 0 terminated or not. Yeah, see, this is the trouble. It is, see, you have the ls and you don't have any 0 termination, so whatever raw data it comes, it maybe get stored in that this thing. I'm not sure. So if that is the case, of course you are not supposed to do a printf like this. Okay, so you need to do some raw binary print of some bytes or something. So that is far better than doing a raw printf. Okay, so anyway, we come back. You should able to see is the architecture is so it is any requests come from this guys from this various clients. So this is the client, and this is another client. So like this you can open multiple clients. Okay, so any request comes, this guy is typing ls and this guy is sending pwd, something like that. It is coming, and then it is putting in the queue. Okay, and then who takes out of the queue, whoever process is that is completely asynchronous. So you can see we should able to go to the thread operation, the thread you can see there you have this thread handle main API. You can able to see the code handle thread, okay, which is what is this thread handle. Where is this thread handle? Let me just copy this. Yeah, thread handle, and you can see there the code is again straightforward. I feel than navigating, I can do it in this yeah, in the GitHub, because it has all these colors and stuff. Okay, so in the thread handle you can see there it is doing a DQ, and it has this P client, which is nothing but an instance of that data structure, and you can see there if it is null, of course DQ can return null if it has no job in the queue, which means head itself is null and stuff. So is checking that, and you should notice whatever the synchronization stuff, this is the reason he is synchronizing, because every time you deal with multi-threading, obviously you have no control who accesses that global context. So you need synchronization, because he had split that into many threads. So since it is split in multiple threads, inside the DQ, internally it happens with the spin locks. So you don't need to do here. If you don't do inside the DQ, then you need to do here. So anyway, it is abstract because it is an abstract API. Okay, so that's why he's doing in the DQ.c I'm sorry, not spin lock, this mutex lock. Okay, yeah, so you can see he's doing that, and coming down, he's taking the connection, and he's getting this handle client something, and then it is looking like a super API. Okay, so which means it may do a lot of work, which means like he's getting these jobs and he's giving to this super API to take care of whatever to be done for that. So in a nice way, he is passing this node or the data structure like a container data structure, like an object of a class. So you have this, put it in a basket and send it off so that somebody else will process that request. So he's pushing this to this data structure, and once it is all done, you can see their connection closed, and is going to iterate this for the next job. And you see this is a generic thread thread handler irrespective of the number of threads. So in the sense, in fact, this tells whatever the common.h he has, the number of thread pool he has is 2. You can make it 3, you can make it 30, you can make it 300 also if the load is more. Okay, so that tells that it can handle any number of such load, okay, coming from the clients. Okay, so that's what he is doing. He is getting that and he is putting that inside this thing. So he is going to handle further. So since this is a common API for different threads, it suggests that all we are trying to achieve, all he is trying to achieve is to load share this job in multiple threads. Okay, so that's the main intent of he having many threads in this code. So it's like that. So it's like you give a job or you call a customer support, and then some random person in that pool in the customer support team, whoever is free, the phone call will get routed, and suddenly he's going to pick the call and he's going to answer you. Same thing it is happening. So here the number of threads you can imagine as the customer support executives in a call center. So whoever is calling, imagine that is the client in this context. Okay, so that's what it is. So handle client, so go up somewhere, you will find handle client. In this whole API, what kind of it intrigues me is he's doing parsing, and whatever the command he gets, you can see their task of command and all that. So task is this client request of this, so he's extracting whatever command you sent, which is actually stored in this some queue or something. Where is that? Client FT and whatever. Yeah, he's doing this read of that buffer. So whatever command has been sent, is taking it and then is running through this huge if else statement. Since it is not an integer or something, he can't do a switch case. So in this case, you need to do this if else. So you see there, if it is ls, then run this link to this ls1 API. If it is cd or something, then do this, and if it is pw, so and so. So that's what he's doing that. And after each API, you can see there, for instance, this ls1 or something, you can see there ls1 is there and is doing all the stuff. And once it is all done, he is going to populate, and you can see there is this send API. So he's just sending this whatever the output or whatever to that respective client who initiated. So he is going to get this reply back. So this is what it is. So you can see there this guy is sending directly, and then he is doing free, close, dir and all. Okay, so it is what it is. So each function is taking it, it is running, and then it is sending it off. There are some